Okay, question number 4. State the conditions for a particle that is acted upon by a system of forces for it to be in equilibrium. Okay, so for a particle to be in equilibrium, the total net force should be equal to 0, and then the net torque should also be equal to 0. Okay, torque. And then question B, a 1 meter rod of mass 2 kilogram is pivoted at point P here. So this is point P. A load of mass 6 kilogram is suspended at one end, and another load of mass M is suspended at Q. Okay, so if the system is in equilibrium, determine the value of M. Okay, so this is 6 kilogram. It's given, and then this is just M. Okay, so before we start, we have to draw the force diagram lah. So force diagram buat di sini lah, number 4. Okay, so assuming this is the beam, let me draw it again. So this is the beam. Okay, and then at one end we are gonna have the 6G, which is the the one end punya mass lah. Okay, wait, and then this is the normal force due to point P, and then we have somewhere around here as the mg, capital M, the other block lah. Okay, and then we have to also consider the mass of the beam. So the mass of the beam, dia punya center of gravity, the weight will be at the center of gravity lah. So center of gravity for a uniform horizontal beam will be at the center lah. Okay, so sorry, saya sedang tengok middle, should be here. Ya, boleh lah tu. Tu lah, 1, 2, 3, 6, 1, 2, 3, 6, betul. So this is the center of gravity. Okay, alright, so ini mg, so I'm just gonna write 6g. So dia sudah bagi kita mass dia 6 kg, and then this is the center of gravity, and then we have been given the mass of the rod to be 2 kg. So this is 2g, and then this is for the block yang dia bagi capital M saja. Okay, this is the normal force due to point P lah. Okay, alright, now let's draw the length. Okay, so this is the length, and then this is the half punya length, and then we have the distance from one end to point P and point Q. Okay, alright. Okay, so this is 0.2 meter, this is point P, this is point Q, and this is 0.3 meter. This is 1 meter, this is half of 1 meter, which is 0.5 meter. Okay, so to solve this, we have to find a rotating axis ataupun a rotating point. Okay, so we are gonna let point P as rotation axis. Okay, so the torque at this point P will be equal to 0. Okay, the total torque at this point will be equal to 0. Okay, so now let's do for 0. Okay, so now let's consider the torque for this one first. So 6g, this is going anti-clockwise. So anti-clockwise going to point P. Maksudnya if they're anti-clockwise, they're positive. So positive 6g, and then the distance is 0.2. Okay, itu perpendicular distance dia kan, 0.2. Okay, and then clockwise will be negative, so minus 2g, and then this distance berapa? This distance we have no measurement for this one. So we have to find lah. Okay, so what is this distance? The distance is 0.5 minus dengan 0.2, which is equal to 0.3 lah. Okay, so dapat jawapan 0.3. Okay, and then lastly for this capital M, this is again and clockwise, so it is negative. So if it's going here, the perpendicular distance is this one, which is equal to 0.3 plus dengan 0.5 minus 0.3, which is 0.2. So this is 0.5 lah. Okay, so minus sebab dia clockwise equal to 0. Okay, so now we are looking for the value of capital M. So kamu rearrange, substitute the value of G. You should then get 1.2 kilogram. Okay, actually you don't have to substitute the value of G when you can just cancel this. Okay, so that is for question 4B. 4B kan? Yeah, 4B. And then question C pula. So now for question C, a uniform rod AB of weight 100 Newton and length 1 meter is hinged at a wall. Okay, so sekarang ni dia punya situation is this rod is hinged at a wall. Okay, lepas tu kita perlu it is supported by a thin wire as shown in figure 8.2. Dia dah bagi figure. Oh, okay, so ni pula. Alright, so the figure is here, so we have to sketch a free body diagram of the rod, then find the tension of the wire, and lastly determine the magnitude and direction of the force on A. Okay, if an object ni kena hinge, there will be a shear force. Okay, so that's why selalu dia begini ni, dia akan kena letak S lah. So it's actually known as shear force if I'm not mistaken. Okay, right, so now let's try to draw the free body diagram for this rod. I'm just gonna draw it here dulu lah. Okay, so this is the rod, and then I think I'm gonna draw yang through square paper lah. Okay, so this is the rod, then dia 1 meter kan. Lepas tu you have to draw the forces. Ni lah look orange. Okay, so it has the shear force. Lepas tu the block mg is somewhere around here lah kali, mg 0.25 kan. Lepas tu ada tension 30 degree. Boleh lah tu 30 degree. Okay, and then center of gravity for this uniform rod, to consider the weight kan. So sini, ting, 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 ting. Kurang satu lah. I'm sorry. Okay, this one is gonna be here, and then this one is gonna be somewhere around here. Okay, so this is the center of gravity. Okay, and then we have the angle 30 degree, and then we have the distance. So this is a berapa meter ni ya? Let me just draw the distance, label the distance. So this is 1 meter, and then this is 0.25, and then we have to also consider this distance. Okay, so that is basically the information needed. This is the 30 degree, this is the tension, and then this is the shear force. This is the mg for the block. This is for the rod. I think it's given W je lah kita boleh tulis. Yes, because it's mentioned in the question that this weight is 100 Newton, so we don't have to put mg, we can just directly write W. Okay, so now the object, the beam and the object is at rest, so we can then find a point to let it to be as a rotation axis lah. So we are gonna use point A here sebab kita perlu cari the value of shear force itu juga kan. Okay, right. Alright, now we are gonna use the table again. Okay, so force, what I said again is from our notes kan, balik-balik guna table. So we have tension, we have weight, we have the mg, and then lastly the shear force. Okay, so the x component is gonna be here, y component is gonna be here, and then this is gonna be the torque lah. Alright, okay, so tension untuk x component, it is negative t cos 30 degree, and then y component there is t sine 30 degree, and then the torque, if it is at point A, is we are gonna use tr sine theta lah. Okay, so t r there is the perpendicular distance, which is 1. Angle there is sine 30 degree. Okay, t sine 30 degree is, we are gonna put this t over here. This is t sine 30 degree, which give us a perpendicular distance here. Okay, so 1 meter. Okay, lepas tu w is clockwise. Kejap, belum lagi pula. Kita buat x component, which is 0. Y component is just negative w. And then the torque, if it is going at point A, this is clockwise, so negative w. Distance there is 0.5. Sorry, I forgot to label this distance. This is 0.25. This is 0.5 meter. Okay. Okay, so mg pula, again, x component is 0. This is negative mg. And then for this one, it is clockwise, so negative mg. Distance is 0.25. And then lastly, for s, we are just gonna put sx, sy, and then since it is located at the rotation axis, this will be equal to 0. Okay? Okay, hopefully you are not confused on how to use this table lah. I feel like it's easier to use table because you make less mistakes lah. But if you like to do yang total force at x, boleh je, tidak masalah. Okay? Alright, so now we can then find the value of tension by using the x, I'm just gonna look. We are gonna use the y component lah. Okay, so total force at y is equal to 0. Why am I confused? Oh, sorry. Okay, so we are gonna use the torque lah. Buat apa mo gina y component kan? So total torque at point A is equal to 0. So we are only gonna be focusing on this side of the table. Jangan tengok yang ini, just focus yang ini. Okay, so total force at total torque at point A is t sine 30 degree 1 minus w 0.5 minus mg 0.25 equal to 0. Okay, so semua ni ada kan value dia. W is 100 Newton, M is given as 10 kilogram. Okay, so kamu substitute sahaja and then rearrange to get tension, which should be equal to 149.05 Newton. Okay, alright, lepas tu we are gonna look for the magnitude and direction of the force on A. Okay, so we are gonna look at the shear force punya solution pula. So this is Roman 3. So this is total force at x equal to 0. Again, focus only on this table here. Okay, so just follow lah apa yang kamu sudah tulis di table tu. Plus sx equal to 0. So sx is basically t cos 30 degree, which is equal to 149.05 cos 30 degree. So dapatlah the shear force at the x component to be equal to 129.081 Newton. Okay, and then now kita akan tengok y component pula equal to 0. So y component kita tengok this column saja. This column on ya, jangan tengok yang lain ni. Tingnan ini saja. And then, tulis je apa yang kamu sudah tulis. So, T sin 30 degree minus W minus mg plus Sy equal to 0. So, Sy, you should get, yalah, kamu terus substitute sendirilah nanti, okay? So, Sy is equal to 123.575 Newton. Okay? Alright, this does not end here. Kita perlu cari magnitude dia. So, S square root Sx square plus Sy square. So, just substitute the values. You should get 178.7 Newton. Okay? And then lastly, finding the direction. Use shift tangent Sy over Sx. So, dapat the direction to be equal to 43.75 degree. Okay? Wow, question 4. Very long solution. But that is basically how you solve for questions yang ada beam lah. Okay, just remember yang the weight untuk the horizontal beam will be at the center of gravity. Okay, so if they mention horizontal uniform horizontal beam, dia punya weight mesti at the center of gravity, which is half of the beam punya length lah. Okay, so that is the solution for question number 4.